Here, the example that I have, f of x is equal to the absolute value of x, and g of x is equal to 3x. So if I were to graph my f of x, then again this would look something like this. It is the absolute value function, which means that coming into the 0, 0 mark, I have a negative 1, 1 slope. Coming out of it, I have a positive 1, 1 slope. If I were asked to then graph g of x is equal to the absolute value of 3x, then what ends up happening with this is it compresses in this direction, because that 3 is a multiplier, and it's always, as you can see, that we always multiply by the reciprocal when it's inside of the function. And so with the 3, it's going to look more like this because it's compressing it inward. So that's what g of x would look like. Another example, if I said f of x is equal to the square root of x, and g of x is equal to the square root of 1/2 of x. So I would draw my square root. It goes through 0, 0, 1, 1, 4, 2, 2, 3, 4, 2, 9, 3, and etc. So that's what that would look like. Now, when I have the 1/2 there, what this does is it stretches it by a factor of 2. So instead of going through the 1, 1, it's going to go through the point 1, 2. Excuse me, it's going to go through the point 2, 1. So I'm going to go 2, 1. And instead of going through the point 4, 2, it's going to go through the point 8, 2. So it's going to look more like that. So when you have a compression or a stretch in the horizontal direction, then we are multiplying by the reciprocal. So we really would like it to be exactly what we expect, but remember we were talking about this yesterday, and we think of this as like when you get yourself a pet or you get yourself a significant other. When they're outside of your house, they're in the range, they do exactly what you want. When they come inside of your house, you come into your domain, and that it does the exact opposite of what you'd like it to happen. So that's where we were yesterday. And so what happens when b is negative, so all of these, if you noticed, is that when b is greater than 0 and when b is between 0 and a 1. So it doesn't talk about when it's negative. Well, when we have, say, I'll do h of x over here, and I'm going to do a square root of a negative 1/2 x. What the negative does is it does a reflection at the same time it does a stretch, and so that's what that would look like. It actually does a reflection. So you'll notice on the notes and in the book, it doesn't tell you about when b is negative or when a is negative, because that's addressed earlier when we were doing the reflections. Is there any questions so far? I'm going to pause this. If there are no more questions, then let's go ahead and move on. So when we are combining them, there is an order which makes your life easier than other orders. Now, order in and of itself doesn't matter as long as you do it correctly, but one order is easier than the other. So let me move over here, and we talked about when we have our f function, so whatever our f function is, and our g function would be a transformation of the f function. So that would be equal to, I'm going to call this big A, f of, let me see, I'm going to use a bracket there, f of b x minus c, and then plus d. So what the A does is it does our our vertical shrink or stretch. But what we want to do first is we first want to factor off any coefficient off of the x. So that's the first thing we want to do. And when it comes to transformations, if we have a number other than 1 as a coefficient on x, we want to factor that off, and we want to do that transformation first if we have one. And when b is less than 0, it reflects across the y-axis. Remember, this is changing your domain. And then the absolute value, so that way we can not have to worry about the negative. If that's less than 1, then it's a stretch vertically, or excuse me, horizontally by 1 over the absolute value of b. So the things you're looking for is whether or not b is 0, whether or not the absolute value of b, and that takes care of when it would be negative, is less than 1. And the other time you want to worry about when b, the absolute value of b, is greater than 1, then it's a shrink or compression in the horizontal direction by the reciprocal. You want to do that one first if you have anything that is other than 1 on your coefficient. Now the second thing you want to do is C. So when you're doing C, you got to pay attention to the fact that it is changing your domain, and you want to do it second. And if it's plus C, then we move left C places, and if it's minus C, then we move right C places. The next thing you want to do is your A, and so you're going to be looking for when A is less than 0. When A is less than 0, we are going to reflect across the y-axis. If the absolute value of A is less than 1, then it's a compression by absolute value of A. Notice that this is not the reciprocal, it's just a strict multiplication. If the absolute value of A is greater than 1, then it's a stretch by the absolute value of A. Now the last thing that you do is you're going to move it up or down. The order doesn't really matter, but you're less likely to make mistakes if you do it in this order. So if it's plus D, then you move up D places. If it's minus D, you move down D places. So the order doesn't matter, but this is the easiest order not to make mistakes. So I'm going to stop here and give you a moment to write all that information down. All right, so let's go ahead and do some transformations. So here is 2 transformations. I'm going to do one off to the side, and that will give you an opportunity to do these 2. So the one I'm going to do is this. That ones are square roots. So let's do the ones like we were working on Monday. Is g of x is equal to negative 2x minus 3, the quantity squared plus 5. So first I'd ask to describe the transformation. So I have to describe what each piece is going to do. So this negative 2 is going to reflect across the x-axis with a vertical stretch by 2. So then what the 3 does, and it's a minus, so it's going to move right 3 places. And then this plus 5 is I'm going to move up 5. So what my original function looks like is this. My original function will go through the point, so f of x is equal to x squared. This is my parent function. And it'll go through the points negative 2, 4. It'll go through the point negative 1, 1, go through the point 0, 0, go through the point 1, 1, and we'll go through the point 2, 4. Now, what I want to do is I want to do this one first. Is I want to take all of my x's and I want to move them to the right 3 places. So I take all my x's and I add 3 to them. So notice I wrote the y's didn't change at all. The y's are maintaining, that they're not going to change values, but I'm going to add 3 to all of my x's. So this is going to go to 1, and then 2, 3, 4, and then 5. So that's the first thing that I did. The second thing I'm going to do, because I didn't have any value as a multiplier right next to my x, is I'm going to go to my y parts. So then I take all of my y's, all my y's are going to be multiplied by the negative 2. So again, my x's don't change, so I'm going to write them as they are. And then I'm going to take all of my y's and multiply them by negative 2. So 4 will go to negative 8, negative 1 will go to negative 2, 0 will go to 0, 1 will go to negative 2, and 4 will go to negative 8. Now, the last thing I'm going to do on this one is I'm going to take all my y's and I'm going to go up 5. So I'm going to take my y's and I'm going to add 5 to them. So 1 doesn't change, the 2 doesn't change, the 3, the 4, and the 5. None of those change. So I'm going to add 5 to all of my y's. So that goes to negative 3. That one goes to positive 3. That one goes to 5. That one goes to 3. And that one goes to negative 3. So I can do this by my ordered pairs. And in fact, if I don't know what the parent function is, or if I have a piecewise function, I have to do it point by point until I get really good at doing the transformations of graphs. So the point, which would have started here at 2, 4, this is where it started, was at negative 2, 4. So that point goes to 1, negative 3. So it goes to 1, negative 3. So 1, negative 3. So that's where this point went to. So I'm going to draw it in blue, and then black is where it's gone to. My next point, which is negative 1, 1, so negative 1, 1, something about right there, it went to the point 2, 3. So 1, 2, and here's about 3. So actually I wanted to do this one in blue and this one in black. Okay, so the other point, which was at 0, 0, went to 3, 5. So 0, 0 is here, here, and I'm going to go to 3, 5, which is up here. My other point, which was 1, 1, it went to the point 4, 3. And my other point, which was at 2, 4, so 2, 4, not drawn well, 2, 4, it went to the point 5, negative 3. So this is my transformed graph. And I'm going to stop and ask you, what kind of questions do you have for me? If there are no questions, then what I'd like you to do is I'd like you to do these, and I'm going to give you some of the points that are on the parent function so that you can do the transformation by the points. So the points that are on the parent function of the absolute value, so I'm going to call f of x being the absolute value of x, it would have gone through the points -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. It goes through many more points, but I'm just going to give you a set of points that you can start out with. On b, the parent function is the square root of x, and it would have gone through the points 0, 0, 4, 2, and 9, 3. Of course, there are many more. There is also 16, 4, but you're probably not going to be able to get that on the graph. So there's the parent function. What you have to do first is you have to describe the transformation, and then you're going to graph the function. So I'm going to give you a couple of minutes to do that, and then we'll go over these. So the transformations that happened on A, so I remembered to actually unmute myself, is this is right 3, and this is down 5. Now in terms of the points there then, so if I add, so it's right 3, so I'm going to add 3 to all of those values for the x's. So it is going to be x plus 3 for all of the x's. The 2 stabilize, the 1, the 0, the 1, and the 2 all remain the same. So right 3 means that this is going to go to 1, this is going to go to 2, 3, 4, and 5. And then the y minus 5 means that my x's are all stable, so 1, the 2, the 3, the 4, and the 5 are not changing. And then what is changing is the y values. So down 5, so that goes to -3, that goes to -4, -5, -3, and or -4, and then -3. So if my original function would have looked like this, so that's my original function, my transformed function is going to go right 3, so 1, 2, 3, and down 5, 1, 2, 3, 4, 5, and it's going to look something like that. So that is my g function. How was that? Any questions on that? Some really nasty looking number 4. So number 4, -4. Any questions on that one? Okay. Oh, yes, thank you. Well, I reflected it because I felt like reflecting it. You're right. Yeah. So just when you thought you understood what was going on, I changed the rules by flipping it, by doing a reflection. There you go. Thank you for catching that. Maybe I was just making sure you all were awake. All right. How was that? All right. How about B? Does anyone have a description of what happened on B? Okay, so we have a vertical stretch by 3 reflected across the x-axis and up 1. So we have this is a reflection across the y-axis. This is a stretch by 3. It's a vertical stretch. And then, of course, this is up 1. Okay, if we do this step-by-step points, then what happens to all of my x's is each one of my x's is going to be multiplied by a negative number. It's going to be multiplied by -1 to be exact. So 3, 0, and 4. That means all of these x's are, well, that's not going to change. That's going to go to -4, that's going to go to -9, and that's going to go to -16. So that's the first part. And then the second part is I'm going to take all my y's, is going to be multiplied by 3. So I have the zeros now are, and the -4, the -9, and the -16 are the values that don't change. And then the values that do change is 3 times 0, which is 0. And then 6, 9, and 12. My last step, of course, is to go up 5, or up 1. Up 1. So the 0, the -4, the -9, and then the -16 don't change. But what does change is I'm going to add 1 to all the y's, so that goes to 1, 7, 10, and 13. So I'm just going to go over here and draw the original function and then the transformed function. So the original function is going to look something like that. That's my f of x. My g of x is going to be reflected in the x direction. It's going to be vertically stretched and it's going to go up 1. So the point that was at 0, 0 here has been transformed to the 0, 1. So it's going to go right there. My point that was at 4, 2 is going to go to the point -4, +7. The point that was at 9, 3, so 9, way out here, 9, 3, is going to go through the point -9, 10. So this is what the transformed function would look like, something like that. Okay, how was that? I've got to ask myself, did I graph it correctly? Because, I put the other one as a reflection in the wrong direction, so you never know with me. I'm pretty sketchy. How was that? Does anyone have any questions on any of that? Okay. If there's no questions, then... Oh, aren't we all a little tired? I don't have a commute, and I don't have to get up at 5 a.m. to get to work on time and all of that, but I feel like I'm more tired now than when I was getting up at 5 a.m. So I get an extra hour and a half of sleep, but I'm just exhausted. I think we all are. So let's keep moving, though. It's harder to fall asleep if you're moving. All right, so we're going to take a look at these graphs, and what we have to do is we have to think about what the original function should look like, the points in which the original function should go through, and then what these points are going through. So which one of these would you like me to do, A, B, or C? A, B, or C? B? Got B, B, B? Okay. So the parent function I'm going to draw here is the parent function should go through 0, 0. It should go through the point 4, 2. So it should look like that. So what I do is I look at my transformed graph. Here is where it moved to. So I know it's going to go down and it has to go left. Now I need to determine whether or not there's any kind of shrink or stretch. So my parent function also goes through the point 1, 1. So what I'm trying to do is I'm trying to determine where the point 0, 0 went to, where the point 1, 1 went to, and where the point 4, 2 went to. So the point 0, 0, it went to, after the transformations, it went to -3, -1. So that tells me right out of the gate what my left, right, up, down movement happened. Because the 0, 0, whether or not you have a horizontal shrink or stretch, is not going to change. But I do know at least where the movement left and right is. So now I'm going to look at my other points to see if they still have that, maintaining that still the same kind of relationship. So the point should have been from the 0, 0. So from my original graph, from the 0, 0, I should go over 1 and up 1. So on my new graph, I'm going to see if it did over 1, up 1. So that one is maintained. The other point is from the 0, 0. I should go right 4 and up 2. So I'm going to see if that is maintained. So from where my 0, 0 gets transformed to, I'm going to check to see if it's right for up 1. So 1, 2, 3, 4, and up 2. And so that looks like it's been maintained. So what that means to me is that there is no horizontal or vertical shrink or stretch. All this is strictly a movement left and right. If it is strictly a movement left or right, then my function f, or g of x is what I'll call it, g of x is equal to, now remember what I have is, if I have some function f of x, then my g of x function would be equal to, I have my a, that is my horizontal or my vertical shrink or stretch and or reflection, f of b, that is my horizontal shrink and stretch, x minus c, that is my movement left or right, and then plus d. So that is my up and down. Now my original function, f of x, would have been the square root of x. So I need to have a movement to the left, and it needs to be underneath the square root because that's what the function is. So it is x, and remember it is the opposite of what I want. I went left, so I think it should be negative, so it is actually plus 3 because it goes the opposite of what you want it to be. And then I finish that off. And then I need it to go down 1, so it's minus 1. So that's what that graph is. This graph is the transformed of the parent function. So that's what that looks like. What kind of questions do you have for me? Okay, it looks like we've got some answers coming in. Now, the first thing is I note where the 0, 0 went to. So the 0, 0, which is right here, it went to here. So this went, 0, 0 went to positive 3 and negative 2. So at least I know my movements left or right. Then what I have is I know that coming into and out of the original function, I have a slope of 1 or negative 1. So I'm going to look for that on my transformed function to see if I have a slope going out of 1 and coming into it as negative 1, and it does. So that tells me that I don't have any vertical or horizontal shrink or stretches. So then it's just a matter of writing the graph with the transformations. Remember, my absolute value function is what this looks like, so it's the absolute value function of x. So g of x is going to be equal to, so I don't have to worry about the a part up here because I don't have a horizontal shrink or stretch, or vertical shrink or stretch. And I don't have to worry about the b part either because, again, I don't have the horizontal shrink or stretch. So all I have to worry about is what c and d is. Now c, because I went right, I'm going to write this as the absolute value of x minus 3. That shows I have a right movement. And it stays within my house. My house is the square root, or the absolute value, so it stays within there. And then I go negative 2, and that is my d value, and so that is that graph. There's g of x. Any questions on g of x? Okay. Now on c, because of the scaling on the y-axis, it looks like it should be a compression, but it's really not because of the way that it's scaled. Because the way that it's scaled, then all I have to do is pay attention to where my 0, 0 went. My 0, 0 went to the point 2, 0. And I check for the other points. If I put in 2, 4 comes out. So I start here at where my 0, 0 went to. We call this the vertex. So we start there. If I go right to, and then I go up 4 because of the scaling, that still works. Had that not worked, then I would have had to adjust for the scaling. So all this simply is my f of x function here. F of x is equal to x squared. That's my parent function. And the only thing that's happening is I have a movement to the right. So my g function, my g of x, is going to be equal to, the right movement needs to come within the house. It needs to come within the squared. So it's going to be x minus 2, because that's the opposite of what we want, the quantity squared. And that's it. How are those? Hopefully not too bad. All right, we just have a little bit more. And with these, what I want you to do is they're giving you the parent function, and they're asking us to write the equation given these parent functions. Which one of these would you like me to do? C? Okay. So C, my parent function is the reciprocal function. So g of x is my new function. I need to make sure it's reflected across the x-axis. So reflection across the x-axis is outside of the function. I needed to stretch vertically by a factor of 7, and I need to go right 1. So the negative outside of my function takes care of this part. Then I'm just going to keep writing it until I've got all the pieces that I need. And then I need to stretch vertically, so that means it's outside of my function by a factor of 7. So I'm going to write this as negative 7 times 1 over x. And then I need to go right 1. So my next iteration of this would be g of x is equal to negative 7, 1 over. Right 1, I need to attach that x minus 1. I need to attach that negative 1 to the x. And so I can write it like that, or I can write it as negative 7 over x minus 1. And that, either one of these, is my final answer. Both of those are correct. Yes, and we can go take a look at the previous one. So the question is, could we go take a look at the previous one and see where the 1, 1 went to? So I'm gonna scroll in here so we can really take a look at this. Now, because of the y-axis being scaled differently, that if I do 1, this is, so if I go 1, that is 1. If I go negative 1, that is 1, because this is where 1 is. So the scaling is different on the y-axis, and that's why I thought initially when I looked at it, and I'm sure you all did too, that there was a compression happening or a stretch happening. And reality is, because the y-axis is scaled differently, it's actually not a compression. As much as we had thought it was going to be cool, but it wasn't. All right, so coming back down here, if you all can do A and B, please. A couple of answers coming in. So the shape of the square root of x, it's going to be shifted left 6 units. So taking care of this piece first, my g of x is going to be a square root of x. I need to go left, so it's going to be a plus 6, because I'm the opposite of what we want. The second thing I'm going to do, so I'm going to rewrite this again with that down. So this is going to be equal to the square root of x plus 6, and then minus 1. And that one is my final answer. Cool. Looks like I'm getting some good answers here. And then we want to take this, we want to reflect it upside down. We want to go right with it, and we want to go up 3. So the first thing I'm going to do is take care of this one. So my g of x is a negative x cubed. That does a reflection across the x-axis. So that is multiplying by a negative in front. Now I want to do is I want to make sure I go right 2. So then that becomes g of x is equal to negative. Going right means I have x minus 2, the quantity cube. And then the last thing I want to do is go up 3. So this is g of x is equal to negative x minus 2 cubed plus 3. How was that? Okay, cool. I'm just going to talk a little bit about this one, which is the last one. And this is what I mean by doing a piece or point by point. So when we're doing this point by point, what we want to do is make sure that we know what's happening with each piece. And we'd want to do this first. We'd want to take all of my x's and multiply by the reciprocal. So you take all the x's and multiply by a negative 2. The second thing you're going to do is this. The third thing you're going to do is this. And the last thing you're going to do is that. So let's just do the first set of points. So the first thing I'm going to do is just write all my points out. Negative 8, 3. I'm going to just go from left to right. Negative 5, 0. Negative 2, 3. 0, 3. 3, 0. And then the last one being 6, 3. So the first thing I would do is I'd take all of my x's and I would multiply. So the x is going to be multiplied by a negative reciprocal. So negative because it's negative to begin with. So all my x's are going to be multiplied by a negative 2. What that's going to do, so that's 3, 0, 3, 3, 0, and 3. Notice I've stabilized my y's for the moment. So this becomes positive 16, this becomes positive 10, this becomes positive 4, this doesn't change. This becomes negative 6, and this becomes negative 12. Keep touching that. And what I'm going to do is I'm going to finish off this video with the transformations, and because I know that I'm over time right now, I'm going to finish off this video with the transformations for this particular example, so you can finish watching it on your leisure if you're inclined. And otherwise, you all have a great morning. Hopefully the rain won't last long. And let me know if you have questions. I have office hours today between 12:30 and 2 o'clock. Let me know if I can help you at all. Have a great morning and a great rest of your day. So now the next step is we're going to take all of the x's and we are going to add 1 to them. So the next step here, actually let me do this in red. The next step is we're going to take the x's and we're going to add 1, because remember it's always the opposite of what's inside the function, inside of our domain. So my x's are staying this, or my y's are staying the same. Okay, and so I'm going to add 1 to all of my x's. So that's going to go to 17, 11, 5, 1, negative 5, and negative 11. The next thing I'm going to do is I'm going to take all of my x's, or my y's, and multiply all my y's by negative 3. So now my x's have stabilized, so 11, and, or excuse me, 17 for the first one. Let me change that to 17. It's a really bad looking 17. So 17, 11, 5, 1, negative 5, and negative 11. And then what's changed is all of my y's are going to be multiplied by negative 3. So this becomes negative 9, 0, negative 9, negative 9, 0, and negative 9. And then my last step is, I'm going to do it down here, is I'm going to take all of my y's and I'm going to add 2 to them. So 17, 11, 5, 1, negative 5, and negative 11 for my x's. My y's become, well, I'm going to add 2 to negative 9, so that makes it negative 7. Then 2, negative 7, negative 7, 2, and then negative 7. So my first point right here, I'm going to call this number 1. It went from negative 8, 3 to positive 17, 7. So let me go ahead and just draw my, let's see if I can do this. Draw my, I want to do, let's see if this is going to work. Nope, that's not going to work. So, let me see. I don't want that. Here we go. Nope, that wasn't it. Oh well. So, I'm going to go ahead and draw my axes here. going to have each one of my grid marks here be worth 2. So this is -2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8. Let me draw that a little bit better. It's terrible. I'll draw this a little bit better. There we go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So my first point went from -8, 3 to 17, comma, -7. 2, 4, 6, 8, 10. So 17. So, and 7. So right there. My next point went to 11, 2. So 11 and 2. My next point went to 5, -7. So 5, -7. And what we just drew is this part. So, excuse me, what we just drew was the curved part. So we just drew the curved part. This point went to here. This point went to here. And this point went to here. Now I'm going to do the next part. So my next point is going to go to 1, -7. So 1, -7. So that's about right there. And I've just drawn that part. And then my last points are -5, 2. So -5, 5, 2. And that is that line. And then my last point is -7, or excuse me, -11, -7. So 2, 4, 6, 8, 10, 11. And then down here to -7. And that represents that part. Now this actually has been it's vertically and horizontally stretched. It just doesn't seem like it because the way I scaled it. So anyways, there it is in all of its glory, transformations of graphs.